Welcome back to Secure 7, your hub for learning cybersecurity, penetration testing, and ethical hacking from scratch. In today's video, we'll be exploring server-side request forgery, also called SSRF. This is one of the most dangerous and underestimated vulnerabilities in modern applications. Why? Because it allows an attacker to make a server perform HTTP requests that the attacker controls. This opens the door to internal network scanning, access to cloud metadata services, credential theft, and even full system compromise. We'll break it all down step by step: what SSRF is and why it's dangerous, real-world case studies where SSRF caused multi-million-dollar breaches, a DVWA-style lab demonstration, the attacker's perspective, how hackers use SSRF to escalate attacks, defenses and mitigation strategies to protect your systems. Stick with me till the end because you'll not only understand SSRF, but you'll also be able to spot and prevent it in real applications. Let's start with the basics. Server-side request forgery occurs when a web application takes a user-supplied URL or resource location, and the server itself makes an HTTP request based on that input without proper validation. This means the attacker can control where the server connects. For example, a website has a feature where users can fetch a preview of a link. The application takes a URL parameter from the user, then uses functions like getContents or curl in PHP to fetch the web page. If there is no restriction, the attacker can provide malicious input. Instead of a normal external link, they provide http:/localhost/admin. The result? The server fetches its own internal admin panel and shows the content to the attacker. This bypasses network protections because the request comes from the server itself inside the firewall. Analogy: think of SSRF like tricking a librarian. Normally, you can ask them to bring you a book from the public library, but if they don't check properly, you could tell them, go to the private archives in the basement and bring me the confidential files. And because they trust your request, they do it. That's SSRF in a nutshell. Now let's see how SSRF has been exploited in the real world. Case 1, Capital One Breach 2019. A misconfigured AWS Web Application Firewall (WAF) allowed an attacker to exploit SSRF. The attacker sent crafted requests that made the WAF query AWS instance metadata. They retrieved temporary IAM role credentials. Using those credentials, the attacker accessed S3 buckets and downloaded over 100 million credit applications. This breach cost Capital One over $150 million in damages. Case 2, Uber Bug Bounty 2016. A researcher discovered that Uber had an endpoint which fetched images from external URLs. By supplying crafted requests, the researcher was able to make Uber's server access internal infrastructure. This SSRF bug earned the researcher a $10,000 reward on the bug bounty program. Case 3, Shopify Bug Bounty. In Shopify, SSRF vulnerabilities were found in their PDF and image rendering features. Attackers could use them to probe internal endpoints like HTTP 7.0.1 where internal services were running. Shopify paid high bounties. Some SSRF reports went up to $15,000 plus. Case 4, Jira GitHub Slack SSRF findings. In some cases, SSRF was used to access cloud metadata endpoints like http://16.254.254/latest metadata in AWS. From there, attackers exfiltrated API keys, tokens, and secrets. Let's see SSRF in action with a vulnerable demo application. From an attacker's perspective, SSRF is one of the most powerful bugs because it acts as a gateway to hidden systems. Here's how attackers chain SSRF. 1. Recon. They find an endpoint that accepts a URL parameter. 2. Internal scanning. They test localhost and private IP ranges like 127.0.1, 10.x.x, 2.168.xx. 3. Cloud exploitation. They target metadata endpoints in Azure, GCP. 4. Credential harvesting. They grab API keys or IAM credentials. 5. Privilege escalation. With those keys, they interact with storage, databases, or even start new instances. 6. Persistence. They upload malicious files or create new accounts with admin privileges. SSRF often doesn't stop at just fetching a URL. It's a pivot point that attackers use to escalate into full-blown infrastructure compromise. So how do we protect against SSRF? Here are some strong defense mechanisms. 1. Input validation and whitelisting. Only allow requests to trusted, predefined domains. Example, if you only need to fetch product images from cdn.myshop.com, restrict input to that domain only. 2. Block private IP ranges. Deny requests to internal IP addresses like 127.0.0.1, 10.x.x.x, 192.168.xx, and cloud metadata IPs. 3. Use a URL fetch proxy. Instead of letting the app directly fetch URLs, pass requests through a secure proxy that enforces rules. 4. Disable dangerous functions. Avoid using raw functions like fileGetContents or curl exec directly with user input. 5. Cloud security hardening. Enable IAM-DSv2 in AWS, which requires session-based tokens to access metadata. In GCP and Azure, restrict metadata APIs with authentication. 6. Network segmentation. Place strict firewall rules so web servers cannot directly talk to internal services or databases. 7. Monitoring and detection. Log outbound requests. Alert when unusual requests are made to localhost or metadata services. To summarize, SSRF happens when a server makes requests based on unvalidated user input. Attackers can use it to access internal networks, cloud metadata, and credentials. Real-world breaches like the Capital One hack show the devastating impact. Bug bounty hunters have made tens of thousands of dollars finding SSRF bugs. Defenses include strict input validation, whitelisting, blocking private IPs, cloud hardening, and logging. This is why SSRF is ranked in the OWASP top 10. The impact can be critical. If you enjoyed this breakdown, hit the like button, subscribe to Secure 7, and don't forget to check out my Ethical Hacking Basic course on this channel to strengthen your cybersecurity foundation. Thanks for watching, and I'll see you in the next Vulnerability Deep Dive.